as we were talking more about quadratic functions, we're going to look a little bit more into maximum and minimum values of quadratic equations. Pause the video here to write all of this down. This is a very important key concept, so make sure you write everything down and even draw the graphs. Let's take a look at an example. We have f of x equals negative 4x squared plus 12x plus 18. And we need to determine whether the function has a maximum or minimum value. So if we're looking at our key concept, our maximum and minimum value concept, we can see that we are going to have our a is negative 4, right? So that's less than 0. So we're going to have a maximum here because we have a negative a coefficient, this number right here. And when a is negative or less than 0, we have a maximum. So we're going to have something that looks like this. So in this one, we're going to have a maximum. So now we want to state the maximum or minimum value of this function. It's not enough to just know that there is a maximum or minimum. We have to figure out what the maximum or minimum is. So I pulled up this key concept that we had from the homework before, and it gives us a bunch of equations or expressions to find certain parts that we're looking for. So we know that from this, and we know from our work yesterday, that our minimum or maximum is going to be at the vertex of our parabola. That is like the tip of our parabola, okay? So regardless if it's positive or negative, it's always the vertex, right? So we're going to first start by finding the x-coordinate of our vertex. So it's negative b over 2a. So I write negative b over 2a. And let's look in our function and find out what these pieces are. So our b is 12, so we're going to have a negative 12 over 2. Our a is a negative 4. So we have negative 12. 2 times negative 4 is negative 8, which gives us 1.5, because negative divided by negative is positive, and we get a positive 1.5. Okay, but this is our x value, and when we're talking about our minimum or maximum, our x value isn't what is being minimum or maximized, it's the y value, because we have this y-axis here, and our minimum or maximum is going to be the minimum on our y-axis or the maximum on our y-axis. Correct? So we have the x value, but now we need the corresponding y value. So we're going to take this x value and plug it into our function to get what our f of x or y is. So we have f of 1.5 equals negative 4 times 1.5 squared plus 12 times 1.5 plus 18. Alright, we're going to get a negative 9 plus 18. 12 times 1.5, it gives you 18, plus 18. And if you combine all of that together, you get 27. So our f of x, or f of 1.5, is 27. So we have a maximum of 27. Now I want to take this information and we're going to state the domain and range of the function. A little typo there. So we're going to look at the domain. So the domain goes with all of our x values. So when we have an x and a y-axis, our domain is everything on our x-axis. So when we have a parabola, our parabola looks something like, potentially like this, right? So our x values are, okay, they can go on forever and ever and ever and ever. So our x values are all real numbers. Okay, so our domain, and here's some notation for domain. So our domain, D for domain, with a little colon, you use brackets like this, and you say all x's such that, a straight up and down bar is such that, and there are a couple of different ways that you could write this, but you could write that from negative infinity, whoa, that did not turn out to be infinity, woo, is less than x, which is less than positive infinity. Or if you don't like that, you could just write the domain is x's such that x is any real number. Okay, little notation for you. Then if we're looking at our range, okay, so our range, we have a maximum of this, right? Our maximum is right at the top, the vertex of our parabola. So we can't go any higher than 27, correct? So we know that our range, capital R, is all y values such that y is going to be less than or equal to 27. Because we can have any y value, because we're going to continue going down, right? But we can't go above 27. Okay, so you could write either one of these for a domain, and then that is our range. I want you to try these two problems on your own for homework tonight. This problem and this problem. Make sure you do part A, B, and C for both problems. I will be checking this so you can get your stamp on this tomorrow.